13. Find a primitive Pythagorean theorem triple whose hypotenuse length is 13 cubed. So I think it's important to start with vocabulary. If we don't know the vocabulary, we really don't know what we're looking for. So primitive, prime, we have prime, means we have no common factors besides 1. Okay, so prime, no common factors besides 1 in itself. Primitive means we have more than one number and none of them are related besides they're all divisible by 1. So in this case, we're talking about lengths. So none of the lengths are common besides we have a factor of 1. Pythagorean, I think, is important just because we need to know what we're dealing with. So this tells us we are going to deal with right triangles. Okay, that'll at least give us something visual to look at. Hypotenuse is the longest side of a right triangle. So we have a visual. Those two vocabulary words give us something to look at. We have a right triangle. Our hypotenuse is 13 cubed. That's what the equation tells us. Pythagorean theorem triple just tells us that they all have to satisfy a squared plus b squared equals c squared. Pythagorean theorem right there. Pythagorean theorem triple, any number that satisfies this or any numbers that satisfy that tell us that, hey, it is a right triangle. There are some ones that we remember throughout our math career. Middle school, high school teaches us them, 3, 4, 5, 5, 12, 13, so on. Those are all triples, but any 3 numbers that satisfy that are Pythagorean theorem triples. So now let's draw our visual again. We know what we're working with. We see something now. So we have 13 cubed. Well, we know to be a right triangle, there's a hypotenuse, but there's also 2 legs. So let's call those legs A and B, just because that's what the formula tells us. So we know a squared plus b squared has to equal c squared, but in this case, this is our c. So we know we have to find something where a squared plus b squared equals 13 cubed squared. So we're trying to figure out what can we put here and what can we put here. We already have this filled out. Well, let's go back to just one of the triples I mentioned earlier, and it had a 13 in it. We have 5, 12, 13. Okay, well, now let's think back to more what we've done throughout this year. We've seen that complex a plus bi relates to this right here. A plus bi, we're going to say equals z. This looks a lot like a squared plus b squared equals c squared. So if we can find the equation that satisfies this, we could probably find the a and b, the primitive a and b that go with that. Well, in this case, this could be our a and this could be our b. So our equation would be a, which is 5, plus b equals z, which is 13 in this case. Well, throughout the year, we've also noticed that we can rearrange those. They're all just coordinates on a graph. They all just have to add up and be the distance of that. C squared away. So I'm going to go ahead and call it 12 plus 5i equals 13. Okay. So now what we have is z equals 12 plus 5i. Well, our hypotenuse that we have to get to is 13 cubed. Well, in this case, z equals 13. So to get 13 cubed, we have to also cube z. So z cubed equals whatever we do to the left side, we have to do to the right, has to equal 12 plus 5i cubed. So now let's expand that, FOIL it out, get a solution for z cubed, and that'll give us our values for a and b for our primitive Pythagorean theorem triple. I like to break it up. You do not have to, but again, I do. You can FOIL, factor, whatever method you like. So first I'm going to find z squared. 144 plus 60i plus 60i plus 25i squared. Well, from now on, I'm just going to go ahead and do I squared equals -1, something that we already know. So this comes out to be 144 plus 120i, which minus 25, which equals 119 plus 120i. So there is our z squared. So now let's take that and use it to get z cubed. We know z cubed is z times z squared, so we're going to do just that. 12 plus 5i times 119 plus 120i. FOIL that out again. 12 times 119 is 1,428. 12 times 120i will give us 12 times 120i will give us 1,440i. Then we have 5i times 119, which will give us 595i. 5 times 120 will give us 600. Remember, I squared is -1, so it turns negative. So this equals 828 plus 2035i. So this is what z cubed equals. So again, z cubed equals 828 plus 2035i. Let's check ourselves. So if this works, we should be able to use a squared plus b squared equals c squared. And none of them, they don't have any common factors, so it's primitive. So let's see if this triple works. So this is going to be my a, and this is going to be my b. So 828 squared plus 2,035 squared has to equal 13 cubed squared. 828 squared comes out to be 685,584 plus 2,035 squared gives us 4,141,225, and 13 cubed squared, which is 13 to the 6th, will give us 4,826,809. Well, let's combine like terms. When we add those two, we get 4,826,809, which we already know also gives us 13 cubed squared. So it does work. So what we get is A, B, C, Pythagorean theorem triple, and it is also primitive. They're all prime with each other. The only factor would be 1. So our solution is 828, 2,035, and 13 cubed is our Pythagorean theorem triple. So we have a really big right triangle that looks something